Welcome back to Seacoast High School's remote trigonometry class. I'm Eric Fearing, my pronouns are he, him, and most of my students just call me Mr. Today we're working on benchmark number 5. Find the value of the sine, cosine, and tangent ratios given the sides of a right triangle. You may want to go back and look at the definitions of sine, cosine, and tangent, where we talked about how the sine ratio is the opposite divided by the hypotenuse, cosine, the adjacent over the hypotenuse, and tangent, the opposite over the adjacent. You'll want to have these definitions handy because writing these ratios when we're looking at a triangle requires first knowing what ratio we're trying to write. So here we have a right triangle with some roughly estimated sides. And we're going to write the sine, the cosine, and the tangent for one of these angles and then the other one. So first, let's use this angle on the bottom right. Remember, we need to have the sides labeled as the adjacent, opposite, and hypotenuse in order to write any of these ratios, and that requires knowing which angle we're talking about. So if we're going to find the sine of theta, the cosine of theta, and the tangent of theta, we got to know which angle theta is. Here we are. Let's label the sides. The hypotenuse, always try to label that first. It's across from the right angle. The opposite side in this case is the short leg, that's 12 because it's across from theta, and that leaves the adjacent side 22.6. With that in place, we're just going to think about what the definitions are for sine, cosine, and tangent. Sine is the opposite side over the hypotenuse. So the sine of this angle, whatever it might be, is 12 over 25.6. And for our purposes today, I'm just going to stop there. I should probably go and get a calculator and turn that into a decimal since we started with decimals and this fraction looks kind of ridiculous, not reduced and with a decimal point in it, but I'm just going to skip that part. We'll do some reducing when we're not using decimals later on, but I don't want to grab a calculator right now. The cosine of this angle is going to use the adjacent and the hypotenuse. So our cosine ratio is 22.6 over 25.6. Your sine and cosine ratios should always give you a proper fraction with a smaller numerator than denominator. That's not true for tangent sometimes, as we'll see in a moment. So the tangent of theta is the opposite side over the adjacent side. In this case, the opposite is 12 and the adjacent is 22.6. This should feel pretty easy if you were good with the definitions of sine, cosine, and tangent from the benchmark 3 video. Now, what if we needed to use a different angle? I'm going to redraw that same triangle with a hypotenuse of 25.6, a vertical leg of 12, and a horizontal leg of 22.6. But now we're going to look at, let's call it angle beta. So instead of using the smaller angle, we're going to use the larger unknown angle. So the sine of beta is not going to be the same as the sine of theta because it has different relationship to the adjacent and opposite legs. The leg opposite beta is going to be 22.6, and the leg adjacent to beta is going to be the one that's 12. So our sine is the opposite over the hypotenuse, 22.6 divided by 25.6, proper fraction, a decimal less than 1 if we went to the calculator, because the hypotenuse is always going to be bigger. The cosine of beta is the adjacent, 12 over the hypotenuse, 25.6. And the tangent of beta, here's where we finally get one that's not a proper fraction, because the opposite is much bigger than the adjacent leg from that perspective. So the opposite side is 22.6 divided by the adjacent side, 12. So that's going to be almost 2 if we plugged it into a calculator. So now let's work on a couple that look a bit more like the homework problems and don't require doing all 3 ratios each. First, we'll do one for cosine. So we're trying to find the cosine of theta. We get told that theta is the bottom left angle. Okay, we have all 3 sides. Happily, there aren't any decimals or anything odd going on, so this should be pretty straightforward once we've written the ratio. Remember, cosine is the adjacent to the hypotenuse. So the hypotenuse is 34. The opposite leg is 30 across the way. That leaves the adjacent leg 16 along the bottom. So our answer, the cosine of that angle is 16 over 34, which we can definitely reduce as a fraction to 8 over 17, which would be excellent. I would urge you not to put it into a calculator here because you'll have to round, and 8 divided by 17 is pretty easy to key in later on or use as a fraction as we go forward. So that would be the best way to submit your answer. Now, here's a problem where we want to know the tangent, and this one's a little more complicated because it's got that square root of 2 in the measurements there. I do need to know that tangent is the opposite over the adjacent, and I'm going to label that with respect to theta. Opposite is 7. Adjacent is going to be one of the ones that touches it, so 21 is the hypotenuse, which means the adjacent leg is 14 radical 2, which must be smaller than 21 because 21 is the hypotenuse, though it's really hard to tell by looking at it whether that's true. So the tangent is 7 over 14 radical 2. This is an okay answer. If you put it into the Google form in this format, I would say, okay, you know how to do the tangent ratio. You've met our benchmark 5 requirement. It's not great because it's not a reduced fraction. 7 goes into 14 evenly, so we can reduce this to 1 over 2 radical 2, which is a better answer. It's not any easier to type into your Google form, and it will drive some math teachers up the wall because traditionally we do not let a square root stay in the denominator of a fraction. So if you really want all the bonus points here, we're going to multiply the square root of 2 by itself so that we get a whole number 2 in our denominator. And to keep the value the same, we're also going to multiply the numerator by the square root of 2. So the best answer, which we would call rationalized, don't worry about that word, is the square root of 2 times 1 in the numerator, and 2 times the square root of 2 times the square root of 2 again in the denominator, which is 2 times 2, or 4. Root 2 over 4 is the absolute best answer. But this one's okay. This one's great. This one's just out of the park. So today we talked about finding the cosine, sine, and tangent ratios given the sides of a particular right triangle. If you have any questions, feel free to email me, get in touch with me via Google Voice, or come to Tuesday and Thursday office hours, 1 to 2:30 on Zoom. If you need the connection info, of course, get in touch one of those other ways or via Google Classroom. Thank you.